before you get too deep into this problem, I want to spot check and make sure that we're doing it right, because there is one word that will trip you up. Okay? All right? So, let's talk bearings here. So, the airplane wants to maintain a ground speed. So that's like my ground, I think Mrs. Hill yesterday called it ground speed. I called it actual or true. Okay? Right? So that's the one that we're dealing with here, is we want this true speed is what we've got. Okay? And so that it's what it wants to maintain is it wants to go at 330 degrees. So that is, oops, that should have been in green. I should have put that one in green. So it wants to maintain 330 degrees. Which is what for a trig angle? What is that one in a trig angle? 120. Okay? That's 120 degrees. Because this angle up in here is 30 degrees. Okay? So my trig angle would come around to there. Yes? Okay? That wasn't the tricky one. Okay? That one was the normal one. Now, let's talk wind. Why is wind the tricky one? It's from instead of to. Okay? The wind is from a bearing of 135. So a bearing of 135 is down here. Correct? But it's from there, which means it's actually blowing to that red direction. Which means that this is an actual bearing. It's blowing to 315 degrees. Which means the trig angle is 135 degrees. Because this would be a 45 degree angle, and so my trig angle would be 135 degrees. Okay? Lukey.
How'd you get 315?
Because I added 180 degrees to 135. Because if it's blowing from, that means it's blowing straight in the opposite direction, which is 180 degrees. Okay? Now we should have enough information to do that problem. Okay? So we can find those two vectors. So my, oops, I should put true in there first. So my true vector is going to be 425 times the cosine of 120 and 425 times the sine of 120, which gets me a vector of negative 212.5 and 368.061. Then I have a wind vector of 25 times the cosine of 135 degrees and 25 times the sine of 135 degrees, which is negative 17.6777 and 17.6777. Yes? Okay. Now, in terms of the math going on here, my plane, the aim of my plane, or what the plane needs to do, plus the wind, is going to give me my true course and speed, my actual course and speed, if you will. Okay? So that means I can manipulate that equation so that if I'm looking for the plane, it is going to be my true course, or my actual, minus my wind. Okay? Yesterday, Mrs. Hill called the true ground. Okay, so if you have a G there for ground, that's fine too. Okay? We differ by that, but we're actually talking about the exact same thing. So we're talking about green minus red. Okay? Green minus red then would be negative 194.822 and 350.383. From that now, I need to find my true, or excuse me, my magnitude of the plane and my direction of the plane. So it's asking here, so then the plane's magnitude would be negative 194.822 plus 350.383. Both of those are squared, and I take the square root of that, which gives me the plane needs to have a speed of 400.904 miles per hour. Do we agree with that? Okay. Then I need to find my direction, so my theta prime is going to be the inverse tangent of 350.383 divided by 194.822. I drop that negative sign on that one. Okay? So that's going to give me a reference angle here of 60.9248 degrees. Agree with that? Okay? Which quadrant is that reference angle, or which quadrant should I say is that theta, my plane here, which quadrant is that in? That is in quadrant number 2. Okay? So if I'm dealing with a quadrant number 2 angle, okay, that's somewhere up in this general area. Yes? Okay? So if I'm dealing with that, then my bearing, remember, my bearing will come all the way around to that angle. So my bearing then, my actual theta, is going to equal 270 plus my reference angle. Okay? Because my reference angle would be there. Okay? So that is going to give me a bearing angle of 330.925 degrees. Okay? Questions on that one? Yes, sir?
Why is it in quadrant 2?
That's my reference angle, that is 60 degrees. My actual vector is got a negative x component and a positive y component, which puts me in quadrant number 2. Okay? Yes, ma'am?
Why would you add the 271 to find the bearing? Why wouldn't you just use the unit circle?
I could use the unit circle, but that gives me a trig angle. I need a bearing angle. Remember, bearing trig is 0 is straight out to the right, and I go counterclockwise.
Does it matter which one you use?
Bearing is 0 is straight up, and I go clockwise then. Okay? So we use trig up here to find these 4, okay, is where we use trig, but we have to switch it from bearing into trig, and then at the end, switch it back into bearing. Okay? The next example that I would like to do is actually on the back page of your, it's on the very last page of the packet. It's the top one. Okay? A pilot is flying with an airspeed of that. However, the wind is from the north at 15 miles per hour. Find the ground speed and true course of the airplane. Go for it. All right, let's talk bearings here. So we've got the pilot is flying with that. So the plane is flying at south 25 degrees west. So this angle in there is 25 degrees. Yes? Which gives me a trig angle of 245 degrees. Agree with that? Okay? Wind is going from the north, which means it is going to the south then, which then that would give me a trig angle of 270 degrees. Do we agree with that? Okay. So my plane is flying at 325 miles an hour. Times the cosine of 245, and 325 times the sine of 245, which is a vector of negative 137.351 and negative 294.55. Then my wind is at 15 times the cosine of 270. 15 times the sine of 270. So that's going to be 0 and negative 15. Yes? Yeah. So my true my actual, if you will, is going to be the plane plus the wind. So I'm going to add red and green. And what is that? 309, negative 309.5. So that's what I'm going off of. So my actual true speed is going to be negative 137.351 squared plus negative 309.55 squared, and then square rooted, which gives me an actual speed of 338.654 miles per hour. Agree with that? Okay. My reference angle is going to be the inverse tangent of 309.55 divided by 137.351, which is going to give me a reference angle of 66.0726 degrees. Which quadrant is this vector in? It's in quadrant 3. So it's somewhere down there, this being my theta prime, but my bearing then would be that angle, right?
So they give it to us in a heading, but you want us to give it back in a
Yep. Well, I'll get there in a minute. Yep. Okay. So if we wanted to, so then theta here is going to be 270 minus my reference angle, which would be 203.927 degrees, but because they gave it to us in a heading, south 25 degrees west, we should give that one in terms of a heading. Our answer should really be given in terms of a heading. Oh, come on now. There it goes. Acting a little goofy again today. So, heading would be 90 minus my reference angle, which would be approximately 23.9 degrees. So that would also be south 23.9 degrees west. Okay. General rule of thumb, if they give your all of the information in terms of a bearing, give your answer in a bearing. If they give it to you in a heading, give your answer in a heading. Okay? Last thing I need to remind you of is the fact that on February 2nd, which is this week Friday, we will be having a operations part of the quiz, which in your white packet is like the first 3 sheets. Okay? It's also very much like the goldenrod worksheet, okay, which everybody has to do. Then next week, Monday, we will be doing the applications part of that, which is going to be very much like the salmon color worksheet that you got yesterday. Okay? There is also, I will tell you this, there is also maybe one on each a law of cosines type of question, okay, that you might need to use the law of cosines in order to solve. Okay? Have yourselves a great, grand, and wonderful